Hello, in this module we are going to cover IRR. Um, with the last video we talked about NPV, and NPV depends on a sequence of cash flows, kind of time series. And one of the entries you have to make into the formula is the interest rate, right? You have to give it the interest rate. An IRR is similar but a little different. It simply calculates the interest rate that the investment makes over time as well. But it just basically comes up, it finds the number which makes the NPV equal 0. So you don't give it the interest rate, you just give it the values, and it tells you what your rate of return is over the period of the investments. In other words, the IRR is the annual rate of return on your investments. It's the average return over that particular timeline. So if we open Winston's worksheet here that he gives us, we have two projects, and we want to find the IRR for each of the projects given the time. So this is the years, and this is the cash flow for project 1 and the cash flow for project 2, right? And I've already calculated the NPV given an interest rate of 0.2 and an NPV given an interest rate of 0.01, so 20% or 1% for each of these projects. And right now, based on the NPV of 0.01, project 1 has the better return compared to project 2. But if the NPV was higher, it would switch. So let's find the IRR for project 1. It's really quite simple. Type in equals IRR. Double click the formula. It gives us a syntax. And all we need is the value, the range of values, right? And I can just pull that down. And now we have the IRR for both of these projects. It's kind of one number that we can use to evaluate each investment. So the rate of return for project 1 over these 7 years is 48%. And the rate of return for project 2 over the same period is 80%. Now, if you notice when I typed in formula, it gave me a syntax, right? The value range, and then something called the guess, right? If I don't indicate anything here, then Excel is going to start at a guess of 10, a 10% annual return, and then from there go up incrementally until it finds the 0 point for the NPV. So in this case, you see the project IRR, right? Just like I did up here for you. I just have already had that finished here. C4 to I4, 47, about 48% to 80%. Now we could do the same IRR formula. I'm just going to copy this, okay? But before I copy it, I'm going to put in the dollar signs to make the range for the array fixed, right? To make this fixed so it doesn't change. And then I'll copy it. Actually, I think I'll do both at the same time. So I'll put the dollar signs in here. This fixes it, makes it absolute, like I talked about earlier in a different video. Copy this and we'll paste it here. And then I'm going to add our guess. So I'm going to put in this column here is the guess, which is negative 0.90% to positive 90%, right? Negative 90% to positive 90%, a series of guesses, which is my best guess at what I think the IRR should be. So instead of letting Excel set the increments automatically and figure it out, I'm sort of adding the parameter. I'm telling it what I want the increment to be. So I'll do it again here. Add add in the guess. Now when I pull these two formulas down, it's going to automatically, well, that's not what I wanted. My mouse isn't cooperating. It's going to automatically fill in the guess based on the value here from negative 90% to positive 90% with a 10% change on each row. And you see that the IRR is the same. There's only one IRR regardless of the guess. So we can be fairly confident that this is the IRR for these two projects, right? So we can be very sure that project 1 has a rate of return of 48% and project 2 has a rate of return of 80%. Now those are pretty different numbers, and looking at those I would say that project 2 is the best project. It produces the best return. But don't forget that scope matters. So you can sort of see that when you're looking at the NPV here, the actual dollar amount gain or profit on this project, for project 2 it's $741, right? But project 1 is $918. So yes, the investment for project 1 is higher, but the total amount of money earned is much higher than project 2. So project 2, you could say, has a better return rate, but not necessarily a better total or a better profit overall. So you kind of need to look at NPV and IRR together to evaluate an investment. It is possible that a range of values our cash flows over time may not have an IRR. The formula may not be able to calculate the IRR. So Winston gives us this example of these 3 time points with these 3 cash flows, and if we put the IRR in there using that range, what we get back is nothing. We get no return. This tells us that Excel was unable to find an IRR for this. We can also sometimes find that we get multiple IRRs for an investment. So in this case, we do the IRR like Excel calculate it without entering a guess. But when we enter the guess using the similar range as we did before, from negative 90% to positive 90%, we see there's actually 2 IRRs there, right? There's 2 of them. This is a bit of a problem. Basically, what we're saying here is that we can't have 2 IRR. So if we find that Excel can't produce an IRR for us, or Excel is presenting multiple IRRs, then this statistic is kind of useless. We should ignore it. We shouldn't use it. All right. So how do we find an IRR if there's irregularly spaced cash flows? So just like with NPV, we had X NPV in the last video, we have X IRR in this video. So the function works exactly the same as NPV, X IRR, right? The syntax is the first range is the values, and the second range is the dates, and this is the rate of return for this range of dates, right? So it's actually negative. That means this investment has a bad or negative rate of return. We did not get our money back. Right? We invested $1,500 and we didn't make even $1,500, so we lost money on this investment. So negative 49. But this is based, like NPV, it's based on different time distances between these rates. So it's producing a rate of return of about negative 50%. Let me check my notes here. So I forgot to mention back here, the reason why we're getting no value here, sorry, or Excel's unable to calculate the IRR, just has to do with the signs here. You notice this is a positive cash flow, negative cash flow, positive cash flow. This one is negative, positive, negative, positive. Well, typically an investment, it doesn't usually work like that. If you notice up here with our original one, we have a negative, which represents the initial investment. And then from there, there is a positive all the way through. The reason why Excel can't find an IRR for these, or has a multiple IRR here, is because of this pattern. So we want to see a kind of negative plus plus, plus, sorry if I can type right, plus kind of sequence here in order to be sure that we're going to have one IRR, right? That's why we got one IRR here. But if we see sort of a negative, or let's say a positive, negative, positive, I wish it would stop that. It thinks I'm writing a formula. Like this, like we see in this example, we're not going to get an IRR. It's not likely that we'll get one IRR. Similar, if the amount goes up and down and up and down, same problem. We're going to get a multiple IRR from, like in this example. So that's what's going on. That's why the formula isn't appropriate to use when we have data that's arranged like this. Just wanted to go back and note that. So what if we borrow money to make the initial investment? What if the money that we're investing is borrowed money, right? In that case, we need to use an MIRR. And this refers to a modified RRR. That's what M stands for, is modified. So in this case, we have the percentage rate at which we borrowed the money from the bank. And then just like with NPV, we have a percentage rate for what we expect that we would have gained from that money if we reinvested. So we can calculate the MIRR and the IRR here. I already have it in here. I'll take it out. I'll just leave the IRR, right? Just using the same kind of formula. We're just running it on this time series of data, the cash flow. For MIRR, type it in. Oops, guess it didn't want to work. MIRR, need a double click. There we go. So according to syntax, the first is the values. So here's our value range here. And the second is the finance rate of our initial investment. There's our finance rate, which is 10%. And the reinvestment rate, what we'd make if we reinvested it, which is 12%. And so the real, you might call it the real IRR, if we had to borrow money to make the investment, would have been 12.6% compared to 13.1%. Why? Because we have to account for the fact that we're being charged interest on this $120,000 every year at the same time that we're gaining cash flow, right? Sometimes that we're gaining cash flow, we're also paying out an interest. So these things have to be balanced. So overall, between what we're paying in interest and what our investment is making in cash flow, the MIRR is 12.6%. As our rate of return on this investment is 12.6%. So that's one thing to consider if you're using borrowed money, to use the MIRR function. So if you want more detailed examples on how this MIRR is calculated, the chapter, Winston, he goes into it in more detail. He provides other sheets, but I'm not going to get into it. If you end up needing to use this in your project, then you might want to go back and refer to the chapter so you can understand the math that's happening here. For the next video, I'm going to skip chapter 10, which is just a laundry list of other financial functions. We have these formulas here, finance, so Winston just starts going through a bunch of these. I would say I'm going to leave it up to you to go through that chapter on your own. If your model, if your project, if you're using dollars, if you're doing some kind of loan calculator or something like that, then maybe you'll need to review that chapter and learn more about these financial functions. But I'll leave that up to you if that's the nature of your project. So in the next video, I'm going to jump into if statements, covering different types of if statements and how to use them, and that's actually 2 chapters in the book. I've already covered chapter 14, this idea of special paste, right? I've done that, or paste special. I've done that already in the tips and tricks video that I made during the first module. So I'm going to skip chapter 14. And what else? Also, I'm going to skip chapter 13, which is just time functions. Time functions is very similar to the other chapter I already covered on date functions. So if you do have a project and you want to enter time values in your model, if you need time values, then go look at that chapter and find out the specifics of the kind of formulas that you can use with dates and time, because they go together here in Excel. So it's just kind of a continuation of the dates video that you already went through. If you want to get down to the minutes and the hours, then take a look at Winston's chapter 13 on time functions. So next video is going to be a little longer. It might be 2 videos, I'm not sure, on how to write if statements. It's a little bit similar to programming, actually, so the first step towards programming. So see you then. Bye.